Hi everyone. So bear with me in my English because I didn't know it was supposed to be in English, so bear a little bit with me. So I'm going to talk about service mesh. First of all, hi, my name is Tiago Maia. I'm the weirdo of the group because I have a master's in software engineering, not software informatics, so I'm sorry. Don't be your colleagues. Currently I work at a company called Farfetch. Sorry. And currently one of the topics that we're working on are containers, orchestrators, and declarative pipelines. But that's not what I'm going to talk about here. I'm going to talk about service mesh. Before I talk about service mesh, it's important to understand how it started. So what is the big picture? What is the problem? So as you all may know, microservices is an architecture pattern that is very adopted nowadays. And people are using it because it has a lot of advantages, right? Teams are now independent from each other. They can deploy it whenever they want. It's much better to scale the application, the service that you only need. But it's not a silver bullet for all your problems. So what's the big problem here? Before we had a monolith, right? And the monolith for your application had all of these features that needed to work, such as security, such as resilience, such as observability and monitoring. So this is what we'll commonly call cross-cutting concerns related with communication. These problems, now that we are using microservices, need to be replicated for all your services. Before we had a monolith, you only create their logic, and I have microservices duplicating the logic everywhere. So this is commonly we have microservice application. We have three services, A, B, and C. Usually nowadays, different services have different languages, like here, Python, Node, Java, and each service has its own stack of dependencies, of frameworks, of libraries, right? You will need security, you need load balancing, you need service discovery, you need, and many other stuff, right? And now with the service mesh, what you basically do is you remove all that logic out of your services and you use a service mesh. So what is a service mesh? A service mesh is an infrastructure layer that is configurable, and the main objective is to remove the cross-cutting concerns out of your service. So your developers can only focus on business logic inside of your application. So infrastructure layer that removes cross-cutting concerns related to communication out of your services. So why is this a problem, or why is this important to document and to talk about service meshes? First of all, it is a recent topic, especially mostly 2 years ago. It was a very hot topic. We still have a lot of lack of information. And another big problem is companies want to sell their tools. Service meshes are mainly distributed by companies. Companies develop service meshes. And when I'm trying to sell something, I'm going to talk very good about my tool, right? My tool is amazing. My tool has all these cool features and powers. But like everything else, it has pros and cons. This is just a cool survey that I found on the Cloud Native Computing Foundation, that about 250 people that participated in this survey, 70% were already using service mesh. So I'm going to talk about those patterns that I documented, very small detail. So a service mesh, as I said, it's a way to remove cross-cutting concerns out of your services. So we have basically two main components, data plane and control plane. The control plane is where the user interacts with the service mesh to specify the configurations needed for your services to work on those cross-cutting concerns. So we have observability, we have security, we have resilience. Imagine you want to say that your services are supposed to do a canary deployment or a secret breaking pattern, right? You can do it by specifying to the control plane, normally using YAML files. And then the data plane is the plane that makes sure that your services are respecting the configurations that you pass by the control plane. This is just an abstract pattern of the service mesh, and then we dive deep into two specific implementations of the service mesh. So one of those implementations is the sidecar. The sidecar basically means that on the data plane, we have a sidecar for each service. So if we're talking about the Kubernetes context, orchestrator, we have our services deploying on the pod, right? Each container has its own pod, and next to each container on its specific pod, we deploy a sidecar container. This sidecar makes sure that all the traffic that is going to the services passes by the sidecar. It makes sure that your configurations of cross-cutting concerns are respected, and it acts basically as an independent proxy for each service. Few companies that use this approach for a sidecar service mesh. Issue Linker Console, the most known is Issue is open source. And for your people that are Amazon lovers, AWS also exists for people that like Amazon. This is a very common practice sidecar approach for big applications that require their services with specific configurations for independent service. So imagine that I need for my service a specific secret breaker, but my pod B doesn't need that. I don't need to do that for the pod B, right? I can do specific configurations for specific services. The node agent is the other approach. The difference is that you only have one agent per node, per machine, and then it enables that your configurations for the cross-cutting concerns are also respected, but it's one agent for the single node, right? So the same concept as sidecar, but you don't have a specific proxy for each service. The proxy acts, the node agent, the proxy acts for the single node, for all the nodes. So all the services inside the node need to use the configurations on the node agent. You cannot specify specific configurations for specific services. So on one hand, you save resources, right? Because you only deploy the node agent. On the other hand, you lose configuration. One of the tools that uses that is Traffic. Maybe you know Traffic because of the proxies. It's a very known proxy, but it also has its own service mesh, Traffic mesh. Shared communication library. Well, this problem of the cross-cutting concerns is not new, right? Microservices is a very old pattern. So people used to have a solution for this, and that's libraries. Netflix, for an example, has a bunch of libraries that they use to tackle their cross-cutting configuration problems like Ribbon or iStreak. And you basically create your features, create a library, and it's used on the different services. A service mesh team. This is a new concept that we created that basically means that in a company you should have a specific team that works for the service mesh. This team has two objectives. First of all, to agilize the process of developing features for the service mesh, helping developers to make the process easy to use the service mesh, and on the other hand, to remove a dependency. So let's go back a little bit. We have a monolith. The monolith, every team is dependent on each other, it's a problem. We go to microservices. Teams, they do not depend on each other, that's good. And now we have a service mesh. Now all the teams that won't use the service mesh are dependent on each other because they need to apply configurations. That's a big problem again, right? And then the service mesh team, what it does is to remove that dependency from teams to teams, and now all the teams depend on the service mesh team, removing and diminishing, sorry for English, the number of dependencies. Last pattern, multi-cluster service mesh, is a pattern specifically for increasing resiliencies and save resources. What it means is that in a big company, when we have a bunch of clusters, maybe from different data centers, we have multiple clusters using a service mesh, so we can use a single service mesh controlling all those clusters. What it enables is that in terms of resiliency, if I want to, for example, increase the version of my Kubernetes, I need to shift the traffic from one cluster to the other, one button. So I can shift the traffic from one cluster to the other, increase the version of Kubernetes, and then change the traffic again, increase the version of the other cluster. This enables a zero downtime upgrade. The other thing is that you can use a single control plane to control different clusters, so saving a little bit of resources. Putting it to practice. The bold question, is the service mesh for everyone? Possibly not. Is it for your context? It depends. Service mesh has positive consequences and negative consequences. On my master thesis, I enter into much more detail about the consequences, positive and negative, and you're free to go and check it out. So it's not only positive consequences, it also has negative consequences, but it's a good improvement, on my opinion. Thank you.